So as we get ready to start lesson 31, does anybody think you know what negative reciprocals might be? Okay.
It's basically like the reciprocal of something, but just the opposite sign.
Okay, so opposite sign, but what's a reciprocal?
Say 3 would be the reciprocal would be 1/3.
The reciprocal of what would be 1/3? I just didn't hear you.
Reciprocal of 3 would be 1/3.
Good. So what Ted is reminding us is the negative means one is positive and one is negative, and reciprocals are you take a fraction and you simply flip it upside down. So if you just want to say upside down, and one positive and one negative, that's what we're talking about with negative reciprocals. Also, we sometimes say opposite reciprocals, sometimes inverse reciprocals. Now I'm wondering if anybody remembers anything about, well, before I do that, let's just get some other examples up there. Ted already gave us, what'd you say? 3 or negative 3? What'd you start with? 3 and negative 1/3. Here's another example, 3/5. Turn it upside down, we have 5/3. First one was positive, second one is negative. Now you guys are going to fill in some of these for me. 5/7. Let's see what would that inverse reciprocal be? And make it the inverse, make it the opposite. So negative 7/5. One positive, one negative, just turn it upside down. For 4, anytime it's an integer, think of it as over 1. So Austin, what would be the negative reciprocal of 4? Negative 1/4. And almost done here. Everybody, what's the negative reciprocal of negative 1? Positive 1. And negative 1/3, that's what we already did up there. Reading my mind today, coming up with one of my examples for me. Now I want to point out one other thing for you. Also, if you multiply a number and its negative reciprocal, what do you get? What do you get if you multiply 5/7 times negative 7/5? What do you get if you multiply 4 and negative 1/4, everybody? So just another way you can think about those inverse reciprocals. So now what I was starting to ask you a moment ago, can you remember any time last year that you needed negative reciprocals? Do you remember any time last year that you took a number and you needed to turn it upside down and take the opposite? There was a special kind of problem that you did some of last year. Just wondering if anybody remembers anything about when that might be. I'll give you a slight hint. It had something to do with certain kinds of lines and their equations. Perpendicular slopes. Exactly right. So, perpendicular slopes are inverse reciprocals or negative reciprocals. Now, help me remember, what does perpendicular mean? What kind of lines are we talking about? Haley?
Lines that cross at 90 degrees.
Okay, lines that cross at 90 degrees. Not just lines that cross. These are not perpendicular. They are intersecting, which just means they cross. But be careful with that. Perpendicular means 90 degrees, not just crossing each other. Now, as you look at my ones on the left, does it make sense that one of those has a positive slope and one a negative? That's why if we have one, we need the negative reciprocal, not just the reciprocal. One's got to be positive, one's got to be negative. If, and I'm just going to make up a number here, if this one with a positive slope was maybe, I don't know, 4/7, so it's not as steep as if it was a slope of 1, does it make sense that this one would be steeper at negative 7/4 when you look at the picture? Because if this was 4/7, negative 4/7 would be just as steep, but this one needs to be steeper. Now the only exception to that is if we have a horizontal line, so just y equals some number, that slope is 0, and then we have a vertical line, so x equals some number. Is that slope 1 over 0? Or negative 1 over 0? That's meaningless, right? Put there a 1 over 0. So that's undefined, but are horizontal and vertical lines still perpendicular? So if it's absolutely horizontal and vertical, you're just going to do y equals and x equals for your equations. Okay, a little bit of notation. We use m for the original slope, or if you want an m with a sub o, for the original slope. So then we take what looks like an uppercase T turned upside down, just so those lines are making 90 degrees. And that means the slope for the perpendicular line. Sometimes we read it as m perp, sometimes you just say perpendicular slope, but that's an abbreviation that we use. So in your formula list, let's get this one down, that if m is the original slope, the perpendicular slope is the opposite of 1 over m. And I'll point out that works even if it's a fraction. If I had the original slope was 3/4, and if I want the perpendicular slope to be negative 1 over 3/4, I need to take the numerator times, flip the denominator upside down, and I'd get the negative 4/3, so that 1 over works even if it's a regular proper fraction, not just, it doesn't have to be an integer in there that it's talking about. Okay, we'll do a few examples of the kinds of things that the book asks, starting with what I think is the easiest kind. You don't need to draw these pictures, but that's saying we have something like, we have this line, y equals a 4th x minus 2, so I don't know, something kind of like that. And then we want a perpendicular one that goes through 1, 2. So we're going to be trying to find this line. That makes sense with what the problem's asking. Now, I don't have to graph that. What is the only thing I need out of that original equation to be able to do one of these? Cooper? What do I need out of this original blue line to help me get my green line? What were we just talking about on the previous slide? So what is the slope of that original blue line?
1/4.
So my original slope is 1/4. Caleb, what is my perpendicular slope? Perfect. Thumbs up, thumbs down. Everybody good with that much? All I needed was the original slope, so I could turn it upside down and change whether it's positive or negative, and then use that for my final answer. So that means my perpendicular line that I've drawn with green is y equals negative 4x plus b. But I need 1, 2 to be on that green line, which means it needs to make this equation true. So I had to put that 1 and that 2 in. Don't switch them. Be sure 1 goes for the x, not the y. And then that's negative 4 times 1 plus b. So negative 4, so add 4. Everybody, what is b?
6.
So then I have to write my final answer for my perpendicular line. Y equals, I know the perpendicular slope needs to be negative 4. Don't go back to the original. Don't forget the x. Plus 6. Y equals mx plus b. Not y equals m plus b. Don't forget the x. Don't forget the b. Don't go back to the original m. Thumbs up, thumbs down. Where are we with that one? Okay, next kind of problem they might ask you. Looks like they're saying the same thing. Here's the equation of line. Get a line that's perpendicular that goes through this other point. The only difference is this time they aren't quite as nice to us. They don't already give it to us in y equals mx plus b form. So we have to work to get there. So we're going to say 9y is negative 54x plus 1. Emma, what do I do next to get y equals, so that it's y equals mx plus b? Say it a little bit louder. What do I have to do to make that y equals? I can't hear you. Speak up. What? I've got 9y equals. What do I have to do to get it to be y equals? When I have 9y, what do I do to get just y? Divided by 9. Sorry, I was having so much trouble hearing. You've got such a soft voice. Can I simplify that 54 over 9? See some heads nodding. What do we get? We get a negative 6x. I don't really care about the 1/9, but that's what I get. This is my original line. So my original slope is negative 6. Madeline, what will my perpendicular slope be then? Change it from negative to positive and turn it upside down. So the line that I want, my perpendicular line, is y equals 1/6 x plus b. This 0.07 needs to be on my perpendicular line, so it needs to make my perpendicular equation true. So I put the 0 in for x, the negative 7 in for y. A 6 times 0 is 0. That goes away, and I just have b as negative 7. Write the final answer for the perpendicular line. Stick with the 1/6 for the perpendicular slope. Do not go back to the negative 6. Y is mx plus b. So 1/6 x minus 7. How about that one? How do we feel about that one? Anybody with questions, concerns, or anything at all on that one? Okay, this last one looks like it's going to be a lot of work when we first look at it, but maybe not. Oh, they don't give me the equation of the first line. And if I have to get the equation of the first line and then get the equation of the second line, that sounds like a lot of work. That helped me remember. Well, I'll draw a little picture, even though that's not required on a homework problem. But just since it's new to help us kind of think through this. We start off with a line that goes through these 2 points. So this is our original one. And we've got 3, 5, and we've got 4, 2. So that's going to be something, I don't know, maybe kind of like that. Does that look reasonable? And so we've got a line that's doing something like that. Then I want a perpendicular line that goes through 1, 4. So maybe somewhere like that. So this is the line I'm trying to find. Do I really need the whole black line? Now let me ask that another way. Why do I care about the black line to get this perpendicular green line? What am I interested in from the black line? Okay? All I need is the slope, right? So I can turn it upside down and change whether it's positive or negative. So all I need is my original slope. So let's get just the original slope. Elizabeth, how do I get that? The black line goes through these 2 points. Tell me numbers I can write down to get the slope of that black line that goes through those 2 points. A little bit louder, please. The fans are going. Okay, 5 minus 2 or 2 minus 5. I don't care how you start, but then I care how you finish. So if we do it this way, then what? So pick either y to start with and subtract the y's on the top. 5 minus 2, but if you do it that way, Elizabeth picked to start with 3, 5. In the denominator, she's still got to start with 3, 5. So 3 minus 4 to subtract the x's. If you started with 4, 2 in the numerator, you'd have to start with 4, 2 in the denominator. 2 minus 5 over 4 minus 3. Either way, you get 3 over negative 1, which is negative 3. So Ethan, what is my perpendicular slope?
Would it be 1/3?
What do you guys think? Thumbs up, thumbs down? Yes, that is the question. All right, I think we all agree with you there. That means our green line is y equals 1/3 x plus b. Is 3, 3, 5 maybe is on that line, we're not sure. But we don't know for sure if this 3, 5 is on the new line. It was on the original line. Looking at my picture, I don't think 4, 2 is on my green line, so I don't want to use those. The only one that I know is on the green line is this. The green line has to go through 1, 4. That means 1, 4 has to make this true. So we put a 1 in for the x, a 4 in for the y. And that means that b is 4 minus 1/3, so 2 and 2/3, or no, 4 minus 1/3 is 3 and 1/3, so 3 and 2/3, so 11/3 for b. Did I get that right? Stumbled my way through it, but 11/3 sounds right. So write our final equation, y equals mx, so 1/3 x, plus 11/3 for the b. Thumbs up, thumbs down. How are you feeling about the perpendicular lines? Okay, and we're going to change gears completely and do some geometry. Now, you've already been working with what we call interior angles anytime you've done triangle sum. You've taken the 3 angles that are on the inside, or they are interior angles. We're going to talk about something today, which is exterior angles. To get an exterior angle, you take your polygon, for us a triangle, and take, at a vertex, extend one of the sides. And then the angle that you get there is an exterior angle. Doesn't matter which sides you extend. If I had done this one, these would have been vertical angles, and I would have gotten the same angle measure. And just so it doesn't confuse us, I won't put those extra ones in. I would also have an exterior angle here, and I could do the same thing here. I could do one at each vertex. Now, we're going to care about this with triangles, and there's something special that happens when we talk about a triangle and an exterior angle. So here's an exterior angle. Here's an interior angle right beside it. And then I'm going to give these other 2 interior angles names just so I can talk about them. Now tell me A plus B plus I equals how much? And what's going to be my reason on that, Bryce?
That's going to be 180 degrees because of triangle sum.
Excellent. That's going to be 180, and that reason was triangle sum. Now tell me about E plus I. What do I get if I add E and I, Pascal? Why? E and I form a straight angle, so they are also 180 degrees. Okay, since everything's equal to 180, that means A plus B plus I is equal to E plus I. So I'm not going to worry about the 180 in the middle. I'm just going to say A plus B plus I equals E plus I. Then I'm going to subtract I from both sides. And I have A plus B equals E. So I have this exterior angle equals remote, means the ones that are on the opposite side of the triangle. So A and B are the remote interior angles relative to E. So a shortcut on problems on your homework sets, if you have a remote exterior, or if you have an exterior angle, take the two remote interior angles and add them up, and that's all you have to do to get the measure of that exterior angle. So the final part for your formula list is to write down that relationship that we just said. And I don't know, when you're abbreviating reasons, you might just do exterior angle or something like that to abbreviate what property you're using when you solve those. And once you have this written down, grab the whiteboards and markers and we'll do a little bit of practice.
Sure. Exterior angle.